Okay, it's time to start the second session of this morning, titled "Making a Killing from 6G Killer Apps: A Pragmatic Exploration." So in this session, we will take a look at kind of what applications do we actually have, and like where is the application scene going in the 6G computing continuum. So we have all heard the promises of like what we should have and what is anticipated. So different types of applications in XR and automotive and healthcare and drones, which are supposed to kind of change the face of the 6G computing continuum. What's the reality? Do we have those apps, and kind of where are we going with this? And also we will take a look at how LLMs are tied into this whole picture. And we will begin with the first speaker from Nokia Bell Labs. So Mikko Uusitalo, who is the head of research department, radio systems research Finland at Nokia Bell Labs. And his talk is about how do you see the, let's see. 6G use case is the Hexa X2 perspective. So stage is yours.
Yeah, thank you, Lauri, for the introduction, and thanks for the organizers for the invitation. So yes, Mikko Uusitalo coming from Nokia Bell Labs and leading radio research department here. And then in this presentation, then in the role of leading this European level, the only European level 6G flagship Hexa X2, and telling about our work on the use cases. This work in Hexa X2 is done in the work package 1, led by Stefan Wendt from Orange. And overall, the consortium is really large. We have 44 member organizations and really well covering the entire value stack, as you can see here. So Nokia myself as an overall leader, and Ericsson in a technical manager role. So before Hexa X2, surprise, surprise, we had Hexa X, and that was setting the foundation for 6G and doing initial work on the requirements, use cases, setting the vision that you see here, vision for 6G to connect the physical, digital and human worlds. So have digital models of physical reality, have digital models of humans, and also enable efficient interaction between humans and the physical world for efficient control of the physical world. And here is also stated the key values: sustainability, inclusion, trustworthiness, that you have heard several times over these days at the event. Then Hexa X2 certainly continues the work on these use cases. Beginning of this year, we launched available from our website the deliverable on this overall approach with respect to these use cases and requirements. So much more on my presentation content available via our deliverables publicly from our website. And then we continue developing these different technological enablers for 6G. And then what is the main difference from this earlier phase of Hexa X is that in addition to creating all kinds of opportunities and ideas, so we also start putting those in a bigger picture and doing more strongly the pre-standardization. So building this 6G system blueprint, the end-to-end system view, what is important and how do we prioritize these technologies, what is important and when do they come. So then UN Sustainable Development Goals, so these are a basis for our work and for many of the 6G related work all over the world. And already 5 years ago here at the Levi event, we heard some initial work by University of Oulu 6G flagship, where this was put very much in the center of attention for building 6G. And great that this has become quite widely said basis, even though, as we also have heard, there is quite much more to do here. And also with UN, the ambition level to reach goals in this domain is already at the time when 6G is just entering the market. So as we heard from Kimberly, so this the ambition was to reach these end results, reach objectives already before 6G is available. Despite of that, this is a very good basis giving us direction, as we definitely are not yet where we should be here. So then going to these use cases. So here also, again, the sustainability from environmental and social economic perspective in the center, and then use cases listed in these boxes around. Then they are grouped into these use case families that are represented by these circles. And in the following slides, I'll go more in depth into these use cases, and from each use case, a representative, from each use case family to a representative use case that's on the top of each of these boxes. So then going to this immersive experience use case family and the seamless immersive reality. So here we have the situation that a human or set of humans are want to interact with each other, want to interact with machines, want to interact with some objects that don't exist in physical reality anywhere, so could only exist, for example, as digital models in the digital world. And using any necessary senses and providing a very realistic way of interaction. So here we are looking at enabling significantly improved quality of experience and enabling living and working from anywhere and ensuring privacy protection as some challenges. On this kind of enhanced quality of experience, so even as an objective that if you would experience some cultural sports events via this, for example, Champions League final, the experience to you would be richer and better even than if you would be physically there. Because with this, you could kind of be anywhere in the audience, or you could be also in the middle of the game and viewing it from that perspective. Then we have been doing sustainability analysis on these representative use cases. And here we have been looking at the handprint, so then the sustainability benefits from environmental, social, and economic perspective, as well as then the sustainability footprints, so the cost. And going through some aspects of this, and as said, more available from our website. So then on the seamless immersive reality, in terms of the benefits from the environmental point of view, certainly a increase in the efficiency of using the resources and reducing the need for large physical spaces. From social perspective, possibilities for enhanced educational possibilities, job opportunities, and enabling participating different kind of social environments. From economic perspective, enhanced efficiency and productivity. Sustainability footprints, environmental point of view, applying mostly to these new cases. As it's something new, you need to take some invest and get some new parts of the hardware, software that requires material, requires energy, and then results in challenges related to this. In social perspective, even though this has a possibility also to bridge the digital divide, but then this would not be, at least from the start, certainly not available to everybody everywhere. So there is also challenges with this inclusion and digital divide with this use case. Also privacy concerns in this social perspective, and in economic perspective then related to this equipment costs and other costs related to setting up this kind of approach. Then for all the use case families, we have also been looking at the requirements and key performance indicators and stating those. Here in this case, quite some requirements for the traffic throughput and some challenges, for example, then with respect to positioning accuracy. Then moving to second use case family, collaborative robots, and here then the representative use case, cooperating mobile robots. So having a set of robots that are helping us, are working together to help us as end users or help us in some business challenges, and using then the network to communicate and put their act together and also sensing their environment. So some challenges here from understanding and addressing these communication requirements of these future machines, efficient resource usage, and adapting to these requirements of the market. From sustainability analysis point of view, for this benefit side, on environmental side, so resource efficiency, on benefits in the social side is helping people to perform tasks beyond human capabilities, so accessibility, augmenting our life, safer work environment, and then from economic perspective, for example, then increased productivity. And on the cost side, for environment, so energy, use of resources. From the social side, then some challenges with respect to changing job roles and different kind of possibilities on that front. And then from economic side, so the investments required. Then on the requirement side, so here, for example, high reliability for the connectivity needed, and also quite some challenges with respect to this positioning accuracy. Then moving to this use case, family physical awareness and network-assisted mobility. So this use case family is looking at this possibility that in 6G we can use this communicating hardware also for sensing and understanding the environment. And here we then have different kinds of vehicles that are relying on the network nodes and devices then for localizing and also further understanding, sensing the environment and coordinating with each other for this mobility. Some challenges here with respect to risks of accidents, energy consumption, cost of transportation, and so on. Then for the sustainability analysis as benefits, possibility to reduce greenhouse gas emissions, reduce accidents, and also then on the social side, these safety aspects are well visible, as well as increased availability of transportation. And economic side, then reduced cost for stakeholders for improved profitability from using the network and so on. And then on the cost side, from environment point of view, also aspects of increased energy consumption linked to these sensing activities and so on. And the social side, then potential risks for privacy. And economic side is then safety predictability risks with potential economic impact. On this key performance indicator analysis for network-assisted mobility, so here one special challenge is then being able to support the connectivity also with quite high mobility. Moving to this use case family, digital twins, and the representative use case, real-time digital twins. So here we are building these digital models of physical reality and can also be wide industrial complexes, large areas like cities or even wider areas. Then as this is real time, so we need to be able then to all the time update and keep the digital model updated to reflect what is the real-time situation. Then the challenges related to the increase the production quality and efficiency, prevent situations where humans are put at the risks, and privacy trustworthiness. On the sustainability analysis, on the environmental benefit side, possibility for increased efficiency, so reduced usage of natural resources, sustainable urban development. On then the social side, reduced dependence on humans, enhanced inclusion opportunities, and on the economic side, economic efficiency improvements, improved resiliency and flexibility. On the cost side, from environment point of view, resource-intensive IoT and material required, electronic waste from the hardware, and social costs, potential risks to privacy, and economic side, then possible increased cost from this complexity of multi-stakeholder ecosystem. From the requirement side, so some challenges with respect to the reliabilities and latencies. Then moving to the use case family, fully connected world, and the representative use case, ubiquitous world. So being then able to help with this inclusion, so provide the connectivity really no matter where you are, with the efficient combination of terrestrial and non-terrestrial networks, addressing this challenge of the inclusion and reducing educational and health service gaps, enable for Earth monitoring and increased network resilience. On this sustainability analysis from environment point of view, preventing travel-related emissions, giving possibility for better collection of Earth monitoring-related data. On the social side, this digital inclusion highlighted, and economic side, improved economic resilience, efficiency improvements from the reuse of resources. On the cost side, increased material and energy use. On the social side, even though then this is again addressing this digital divide, still also, if not done correctly and user-friendly and so on, there is also possibilities for some problems with this digital divide. And then economic side, profitability challenges and resilience challenges. Requirements and KPIs. So here this availability is of central nature. And then moving this last use case family, trusted environments, their human-centric networks. So for example, sub-networks surrounding a human or set of humans, and providing different added value via this for precision healthcare, enabling this real-time update of digital models of ourselves for preventive healthcare and other usage, safe environments, and so on. So these challenges related to this health monitoring and delivering safe environments. Sustainability analysis from environment point of view, potential reduction in greenhouse gas emissions and reduce, for example, in medical waste. Social sense, this availability of human-centric services, safety, and on economic side, efficiency improvements. And then on the cost side, increased material energy consumption, social costs, privacy, risks related to quite sensitive information, and then on the economic cost side, pressure on demand side can impact efficiency. And then on the requirement side here can be requirements for quite high data rates, and also reliability, as well as positioning accuracy. So those were the use case families and representative use cases that we have been published from the European level flagship HexaX2. And then looking at the worldwide activities in this front. So ITUR has set up this basic framework and time plan for development of 6G, and they have 6 usage scenarios identified. So continuing from IMT 2020, which is the triangle here, so extending that for this massive broadband to immersive communication, and then the massive machine type communication, extending that, as well as building on top of the 5G URLLC. In addition to this, there are 3 new scenarios, one on integrated sensing and communication, AI and communication, as well as ubiquitous connectivity. So then these are further complemented by 4 overarching aspects, including security resilience, connecting the unconnected, sustainability, and ubiquitous intelligence. So there is quite good alignment as expected here with respect to the work that I just presented. And all over the world, of course, there are national, regional activities pushing towards the views on 6G development from their perspective. And then here is some analysis from HexaX2 on then the situation with respect to looking at these different initiatives. And we can see that for this extreme communication requirements, all initiatives have further pushed the limits of these current 5G capabilities along the axis built from 5G. And all these initiatives have acknowledged the need for ubiquitous connectivity, both indoor and outdoor. Concerning technologies, immersive experiences are frequently mentioned, as well as digital twins as well. And on new capabilities getting attention, so AI is strongly embedded in the 6G designs, and the use of robots widely mentioned, as well as this sensing, positioning, tracking. Then an area where there is more variation is this sustainability. And here, so there is more diverse approaches. Energy efficiency, CO2 reduction are widely mentioned, and there are also elements and activities on this wider, more broader sustainability challenges, but that is certainly an area that could require more global attention. So there is room for improvement, especially in that domain. Then, not having time to go in depth here, but just marketing that in HexaX2 we have been also working further on the business models, and we have then material analyzing these different use cases from that perspective, looking at the supply side, value propositions, demand side, and outcomes in this kind of business model canvas. And then looking at the stakeholder analysis, looking at different kind of stakeholders, their roles, value propositions, activities, and resources, as well as also building this kind of ecosystem pies, where these different stakeholders are put in the same pie, showing them and their roles. Then also a couple of words on challenges and risks with respect to these use cases. So there is certainly challenges and risks related to trustworthiness, and also learning from earlier generations. It's good to try to aim as much as possible for early engagement of the stakeholders. There is challenges with respect to energy spectrum and materials reuse and circularity. need for cost-effective infrastructure and services, and need to consider new business models to be better able to tackle this cost effectiveness. Some holistic challenges, as there is a higher richness in the drivers for 6G from these values from sustainability, balancing the trades-off also across these different axes of sustainability and also inside the same sustainability axis. We need to detail the use case and the context, the conditions, the implementation approach, technology enablers. We need to look at cross-sector challenges and risks. So also this kind of balancing the axis inside the sustainability axis. We need to look at the different mitigation strategies related to the technology related to this design of the blueprint. Also then all these policies, regulations and standardizations. And we have stakeholders that have the know-how, authority, capability to apply mitigation strategies also as part of this business ecosystem. And that is then important to pay attention to. So that concludes my presentation. Thank you.
Thank you very much, Mikko. I think we have time for a few questions, so go ahead. Can we have a microphone?
Thanks, Mikko. Could you explain, sorry, Joseph Noll, University of Oslo. Could you explain to what extent the use cases are driving the technology, or to what extent the technology uses the use cases as, yes, it works?
Yeah, so both of these directions exist, and then one question is that what is then the balance? And one thing is that as an industrial field, as a research field, as an academic field, of course, we want to move forward. We want to improve everything that we are doing. And we want to see different ways and how can we improve. So then it is then a duty, especially for this kind of big consortia where players are coming together to formulate these top-down views and to collect the information, collect the understanding, and kind of create the momentum, shared understanding why new technologies would be needed, and try to understand what are the pain points, and kind of try to understand as much as possible from the perspective, what do we really need? And aim to have that as the primary driver for everything which is being done. Yet also, as the world is moving forward, so then also there is the aspect that that different kinds of players have ideas how they could improve this or that technology, and then they are pushing that forward, and also can be in a mode that then they try to find like ways that how could I then use this improvement. Yeah, both of these axes exist as a like a sector of society. We all want that for whatever we are doing, there is some usage for that. So in that sense, as a community, we are pushing to try to find a meaning. But in the end, also in commercial sense, whatever we do, there is no commercial success. It will not become reality. It will not help the society unless there is a real need for it, and so that also the need can be realized in a commercially sensible way. So yeah. Was there some aspect, Joseph, that I didn't answer?
So a very quick question. Will you focus on, in particular, on sustainability use cases. So use cases related to sustainability. To exemplify, you have in 3GPP now, I think release 19, you have in SA1, you have discussion about energy efficiency as a service, energy consumption as a service brought to the service level. Will you come up with any kind of use cases of that kind in HexaX2, or you have a different part related to sustainability?
Yeah, so sustainability is and needs to be a very central driver for 6G. That we have heard many times by many people, and your question is also kind of behind that. There is that thinking, and then in HexaX we had a use case family that was collecting together the different use cases that help with the sustainability. But actually then for HexaX2, the updated version which you see here, we had more the approach that like everything that is done and all the use cases should be taking that sustainability as a central item, and therefore we don't have like a special use case family now for that, but then try to take that into account in all of these different parts. And yeah, these are to a varying degree contributing to sustainability, and also there should not be 6G unless it is sustainable. So the whole approach overall needs to be fulfilling that requirement, and these different parts are contributing to various degree to that.
Hello, Roope from Silo AI. Thanks. Very comprehensive set of use cases and areas. I'm just wondering, like, there was a so large amount of the use cases, and some of those were still pretty high level, and then you have a big consortium on driving those forwards. Do you have any best practices on kind of how can you together dig deeper into the details and kind of ensure the alignment between the parties and kind of going to the nitty-gritty details?
Yeah, so certainly we are expanding from this, and also, of course, have gone further than what was possible to show here. We have still in this project format, so we are still running for around 1 year and 3 months, and we have a timeline where there is interaction between this work package 1, looking at these use case and requirements, and then the other work packages that are developing the technology to realize these. We have interaction inside the project, and we are also organizing interactions with different kind of activities outside the project. And with these interactions, the technology developers get a better understanding and can give feedback back, and then can see that how well are they on the requirement map of fulfilling the requirements.
Okay, thank you very much, Mikko, and let's give a big hand. Our next speaker really does not need any further introductions, so we have our Matti Latva-aho, leader of the 6G flagship research program, and he will be talking about 6G, metaverse and resilience, friends or foes.
Good morning, everybody. And we are still quite numerous, although we are the last day of the event. Thank you for that as well. So I was replacing at the last minute somebody else who couldn't make it after all. So I was thinking, what could I talk about here? And I was thinking a little bit that what is really missing in the bigger discussions in the global community currently. And I think resilience is one of those. There might be some others as well. So a little bit of background, if you don't happen to know yet, flagship, we started already 2018 and have been up and running quite a while. So as Mikko pointed out also in his presentation, when we started our flagship UN SDG goals was really the main driving force from the very beginning of our flagship, and it has been really influenced all of the technical research we have been doing. And then we started to think about, okay, is it time a little bit to update the main message that we would like to convey in the rest of flagship time, and if so, why we would be doing that? And I'll try to explain it a little bit in my presentation. In our flagship, we have clustered our fundamental research to 4 areas: wireless connectivity, device and circuit technologies. Arno Pärssinen will be talking about some of those activities later today. Distributed intelligent wireless computing. Miguel will be talking in this session about those activities. And by the way, on wireless connectivity, Professor Markku Juntti will be presenting on some of our wireless connectivity research later today. So we try to capture most of these fundamental research areas. And now we have also the services and applications, which I'm highlighting a little bit from a rather specific viewpoint in my presentation here today. We do have in our application-oriented research also test network setting, which is actually in collaboration with VTT, Aalto, Tampere University, and some others. And so we have a national test network that we can use to test all sorts of applications of the future. We have different capabilities in that and over there, and we are all the time developing it to be 6G ready with the new radio capabilities once we have these proof of concept radios available. So that's a really nice sandbox for doing all sorts of trials. In our research agenda, besides doing a lot of research on various technology areas, this is not even covering all, we have been very actively addressing from the very beginning, like I said, the sustainability development goals, but also looking at future business potential related to 6G technologies in the future. What could be the game changers in the future? What are the gaps that we need to fill in to complement the great impact of mobile network operators? And we have been focusing quite a bit of our research to different vertical applications. Also, regulation-related work is extremely important, of course, in telecommunications sector. And we have Maria Matimikko-Blue has been very active there, contributing to, for example, ITUR use case definition for 6G, and also in the future on 6G requirements. I'm not talking about only telecom regulation, but it's important to understand some of the constraints coming from different critical vertical areas, like automotive sector or healthcare or whatever, so that where are the constraints, and can we really try to influence on the regulation aspects of those fields, so that in the future different things, automating our daily lives would be possible. And one example of such activities that we have 6G ESS, it's actually healthcare and energy systems combined to 6G technologies, is another program in parallel to our flagship that is operated at University of Oulu to try to understand those sectors far better. So if we look back a little bit, what were the kind of slogans or starting points when we were starting to do research on 4G, 5G, and now 6G? In 4G era, 2003 or so, the slogan was always best connected, and the thinking was that we have all kinds of access networks around us, so the system should be able to automatically scan and use the best possible access technology available for various different end user applications. Even today, we are not that close to that yet, but hopefully we are getting closer to that. When 5G was being developed, it was all about, besides mobile broadband, IoT to be integrated as a part of mobile networks. And lots of things are happening right at the moment there. And there are several different wireless technologies that can help us making it real. It's not easy to say what is really the kind of slogan for 6G. There are so many different application scenarios that Mikko was already explaining, but I think one which is quite unique is this 6G enabled metaverse that is really driving us researchers to future. what it means to us, it's probably different for each and every one of us, but it's massive digital twinning. It's really amazing visual experience of the user and trying to bring in the real life scenario close to us and visualize it to us no matter where we are. And Miguel will be probably talking about quite a bit of those in his presentation. So it will require huge transmission capacity and computational capabilities of the whole system in the future. And that is probably which has been driving us so far mainly. Is that enough is the question. Verticals should be influencing much more on the development of 6G standard than has happened in previous standards. And we have to understand that in order to fulfill energy efficiency of the future systems, as one example, we really have to optimize the operation of the network and also the end user devices and applications for each and every critical vertical separately. We cannot use exactly the same technology, same devices for all of these, which are highly varying. And also the cost of network investments is also highly varying, not to mention the end user devices that they have really must be designed quite differently for all of these. So there are different drivers that we have been talking about over the years that are really pushing us and giving us the motivation to develop 6G, and there are many of these. So I collected some of these, and you can categorize those to societal, business, standards, and technology-driven things. So as societal aspects, I think digital inclusion is one of the key ones. We want to make sure that everybody anywhere is connected. And digitalization of society is really the reason for doing that and trying to accomplish it. If we rely our personal life's health to mobile networks, I think it's pretty important that we are connected anytime, anywhere. We are far away from that yet still. So lots of things to be done. Lots of challenges related to emerging economies, poor countries. What should be the best solution for them? We shouldn't forget them. New ecosystems and business models through verticals, there will be a huge number of emerging ecosystems having their own needs, own players, and that is a fact that is happening already now. And we shouldn't even try to master them to be very homogeneous type of playgrounds where traditional MNOs or traditional manufacturers can somehow try to control, so to say. Global collaboration and standard is, of course, one driver. We all would like to see one global standard happening, and due to really challenging geopolitical situation now globally, I think global collaboration is probably more important than ever before, not only in our field, but in general all sectors of society. And this type of events are, of course, helping us to understand better the different viewpoints and different requirements and different ideas. Privacy and security aspects are really becoming more and more important. And if we have so many different verticals, everything is, and actually mobile networks becoming part of critical infrastructure. They are already, and increasingly so. Privacy, security, trust issues are so important and can be really the biggest bottleneck or biggest point of failure in the future if not taken care of properly. Service-driven architectures, so there might be in the future lots of different access technologies available, and we as end users or whatever is the end user, even machines, they don't really care how do I access to my services and how do I have access to my own data. So the data should follow the persons. We should use all possible means for communications. So services should be defining how the network is used for the benefit of end users. We should not be tied too much to access technologies or our operator agreement even. So in the future, we have been talking about a lot, for example, to enable national roaming in the future, which would be benefiting lots of different types of application scenarios. Super efficient local connectivity, that is really what we believe is the key for enabling one day this metaverse type of applications. We are doing, for example, in Arno Pärssinen's group, sub-terahertz RFIC research, trying to make these gadgets reality. And we understand that at very high frequencies, for practical reasons, with practical size devices and also energy consumption, the connectivity range is rather short. It's very limited. It's probably room size range. So we can yet use that for enabling this type of services in the future in different hotspot areas as we wish. And then AI, we have been talking more than enough already during these few days. No point to mention that any further. Now, having all these things, are we really covering all corners sufficiently enough? So are these really the sufficient drivers for us? Since the world has gone a little bit crazy, we have lots of really nasty things happening around us, and maybe we should also look at a little bit the societal demands more now, right now, because the world has gone crazy, and we can do our little bit in trying to make our society more robust against external interruptions or harassment, so to say. So I think besides UN SDGs, we should be talking much more resilience of the society. Resilience of society is really huge, broad area, and it's so huge problem space that it's even difficult to grasp. I do remember 5 years ago when we started to talk about UN SDGs, and it's very difficult to quantify what does it mean, and it's so multidimensional as well. This is quite similar, and there are touching points to these UN SDGs as well. And there are some of the issues that you can think about when talking about resilience. And now thinking, have we done enough in resilient design of 6G explicitly? I don't think we have done much explicitly for that. It is implicitly part of most of the important activities like HexaX2 in Europe, but not explicitly in the front lines of the project. And I think this really deserves to be addressed much more seriously. There are a few activities already going on which relate to these things. I collected few of those that I found from internet. And most important probably has been this RINGS project in the US, and now they are planning RINGS 2.0 as well. Business Finland is now launching this digital resilience program. So things are happening, and we have to really try to accommodate these things as a part of 6G development. Quite recently, US-led coalition made a joint statement on 6G design principles that 6G should be secure, open, and resilient by design. 10 like-minded countries signed this, including, for example, Finland. So there were 6 principles that are listed there around these design principles, and there are many things that are really related to national security and resilience, but also there are issues related to manufacturing and spectrum issues, etc., etc. One thing actually that is happening as an example, as a last thing that I want to show you, that Finland joined NATO last year, and as a part of these new possibilities that open to us, we actually applied to become NATO Diana Test Center cluster. And in Finland, we have a couple of clusters that exist in Oulu and Espoo. And we are, for example, collaborating with VTT in the 6G test center activity. And our target is to investigate dual-use, 6G dual-use technologies within this context from national security perspective. But I have been already, this is in very early phase, happened just a few weeks ago, and we are making now some planning related to this. I've been telling to our guys that let's look at it a little bit broader than national security. Let's look at it from resilience perspective primarily, more than anything else. And then lastly, I want to remind you that 5 years ago when we were having a 6G summit here in Levi, we initiated a series of white paper writing processes. And they have been quite nicely accepted, downloaded over 1 million times. We might start to do another white paper around resilience, and try to impact on ITUR 6G requirement specification work through that work as well. So next year, IMT 2030 requirements will be nailed down, I guess. And before that, we could try to also feed in inputs from resilient 6G design perspective. Challenge is, how can we measure resilience? What should be the metrics? Can we put some numerical values for those? It's not easy. Easy things are always done, but it means that there's also a chance for us researchers to try to innovate and suggest new ideas. With these words, I think it's time for me to end my presentation.
Okay, thank you very much. And there are questions in the audience, so the microphone, please.
Thanks so much, Mikko. I really love the words on resilience. Though I'm really challenging, I'd love to challenge you to invite for a workshop on the global challenges. Because I really believe that we need to break down the global challenges, being it resources, repairability, being it CO2, being it the whole value chain of AIDS, of catastrophe, of women empowerment, of what you name it, into where is the role of future communication. And it's a lot more than just the resilience. So I'm looking forward that you invite us for a workshop or whatever you have ideas on.
Very, very good suggestion and comment. But I would like to throw ball back to you as well, that saying that when we, for example, talk about women in engineering as an example, that is part of resilience, really, if you think about it broadly enough. But I agree, I agree, and there are so many global challenges, and like we started from UN SDGs, for example, it was so broad, and there's so many questions that it opens, and it's very difficult to touch it in concrete terms and start to do, as an individual researcher, anything supporting that, something concrete. I think it's a bit similar, but it's of course important to understand and paint the big picture, and then because the politicians would need this justification, and without politicians acknowledging the importance of all these things, they will not allocate funding for research programs that keep us running.
What is happening in the energy world is currently that we are defining the energy twin to actually tell how do we get from the components up to the reporting on the 55–60% cut by 2030 and the 95%. That is the same kind of value chain. When you talk about 55% cut, 95% cut by 2050, then you need to break it down. What does it mean for the sectors, for the specification? And that same process, I'd love to see initiated from the flagship to actually see where is the role of 6G in that picture.
Great proposal. We'll be back and discuss more.
Yes, thank you very much, Matti. Okay, so the next speaker will be Dr. Satoshi Konishi from KDDI Japan. So he did his PhD in Waseda 2006, MBA Globis University 2017, has received multiple awards, head of Mobile Access Technology Division at KDDI since 2014, head of Next Gen Networks Development Division since 2017, and now head of Advanced Technology Laboratories of KDDI Research since 2020. And he's talking about possible use cases. So, floor is yours.
Okay, thank you very much for inviting me, and thank you for your kind introduction. My name is Satoshi Konishi of KDDI. I have been with KDDI for a long time, but today I'd like to talk about possible use cases which are driven by beyond 5G promotion consortium in Japan. So today, I don't want to talk about the activities of KDDI. Rather than that, I am focusing on the activities on beyond 5G promotion consortium. Well, before going to the main topic, I'd like to make an announcement to you. As a matter of fact, Beyond 5G Promotion Consortium was merged with 5G Mobile Forum, and a new organization is named XG Mobile Promotion Forum from this April. So please remember this new structure in Japan. Okay, let me go on to the contents of our white paper, Beyond 5G white paper. So Beyond 5G is a kind of broad terminology. So that includes not only 5G advanced or so on, as well as the 6G and 7G maybe in the future. So that covers a variety of use cases as well as possible technologies. Before going to introduction of the use cases, I'd like to introduce a little bit about our structures. So I am a leader of Vision Working Group, but this white paper subcommittee was led by Mr. Nakamura of the entity Docomo. And in addition to Vision Working Group, there are 3 groups under the subcommittee of white paper. And I'd like to thank many members of Beyond 5G Promotion Consortium to have a great contribution to finish this white paper. While Beyond 5G Promotion Consortium has released continuously from version 0.5 in 2022, and we also contribute to our contents by submitting our contents to ITUR Working Party 5D. So as you know, recently, Working Party 5D as well as ITUR SG5 have approved a new recommendation named M.2160, which is also called IMT framework. So our last version is 3.0, which will be contributed to next meeting of Working Party 5D as well. And well, I guess that a new report will be issued from Working Party 5D as well. Well, this is one of the great contribution for IMT 20 ITUR recommendation 2060 or IMT framework recommendation. So this is the diagram or picture what Beyond 5G Promotion Consortium proposed, talking about what Beyond 5G or 6G is. So, well, the picture is a little bit vague, but the point is that, well, 6G or Beyond 5G is an evolution of 5G. So the triangle, you can see a triangle at the bottom of this slide, and then, well, evolved to hexagonal figure. So there is 6 vertices, as you can see, and so those contents or usage scenarios on the vertices are captured in the ITUR Working 5D recommendation, as you can see. So as I said, many things are adopted in the ITUR Working Party 5D successfully, and we are very happy to that. So let me show you the contents of the our white papers, and there are 7 chapters, as you can see, and it contains more than 300 pages. It's a very big white paper, but well, due to the limitation of time, and we like to focus on the use cases, I'd like to show you a little bit about these 2 chapters, chapter 4 and 5. Let me well digest the contents of chapter 4 and 5. As you can see, I think whole industries are covered in a white paper. So as you can see here, railways, automobile, machinery, space, and so on, everything is captured to understand what kind of use cases would be toward the beyond 5G and 6G era. Well, by summarizing use cases and requirements from various industries, we also captured requirements, capability required to beyond 5G in chapter 5. So let me pick up several important and interesting requirements from various industries. The first one is the media industry. So, well, as Marty and other people said, many people are eager to see a new business like a metaverse or so on. So people intrinsically want to see a new world with realistic and beautiful image and video. So needless to say, people want to see 3D instead of 2D sooner or later. Well, considering that the requirement in terms of throughput would be tremendous compared to the 5G era. So when we calculate the total amount of throughput required to 5G or beyond 5G era would be few hundreds gigabps. So next thing I'd like to introduce is the machinery industry. So machinery industries covers a variety of industries, as a matter of fact, like not only equipment, but also agriculture and electronic and so on. Well, this is a little bit busy slide, but what I want to well, share is that, well, they require very short communications. Well, many factories want to replace their Ethernet cables or wired cables to wireless because they want to replace or change their production lines so often compared to the past. But well, what they have to do right now is that they have to deploy cables again after change the production lines. It's a huge amount of burdens, as well as it takes a lot of time. For example, 2 weeks or 3 weeks for changing a line. So it will, well, stop the line, needless to say. That means that they lose the opportunities to gain money. So they want to replace Ethernet cables or wired cables to wireless. But unfortunately, they don't rely on wireless. So I think there are many wireless engineers. They don't just say that they don't believe wireless engineers, but they cannot believe wireless lines because of the unstable links, and we cannot ensure that bandwidth or throughput all the time. So what we have to do is that how to ensure the wireless link more stable. And well, in order to replace their Ethernet cables or wired cables to wireless LAN, they require us to have a very short range communication, like 100 microsecond, 0.1 millisecond in end-to-end. That is a very high demand, but well, why don't we tackle with this very high demand toward the 6G era together? Well, next is automotive industry. Needless to say, this is one of the very aggressive industries. They want to well, introduce a variety of new technologies, including ICT, as soon as possible. And they have a variety of visions like smart cities, collaboration, and automotive, well, movement and so on. Well, needless to say, they need a lot of requirements like high throughput, like 50 gigabps with 1 millisecond end-to-end latency, and high reliability, like 10 to minus 6. Healthcare is also important for everyone in the world. where people want to live longer, but the problem right now is that how to diagnose automatically and in real time. So, well, some people say that each person may have a more device to identify or diagnose or capture the latest situation or body, so that we can send those data to server, and then doctors can, well, maybe doctors or other AI machines may automatically identify what kind of problems you have. So considering that, we may support a variety of devices as well as a bunch number of devices like this. Well, due to the limitation of time, I like to stop here about introducing various industries requirements. But from now on, I'd like to show you the summary of requirements. So this slide shows that a broadband perspective, and there are a variety of requirements from many industries. But in a nutshell, what I can say is that up to 300 gigabits will be required to be on 5G or 6G era. The next one is regarding low latency. And as I said, the very high hurdle is that 100 microsec. But that is not including the internet, of course. They think about the total latency will be inside of the factory. The next one is the reliability. That will be also very important towards 6G era. And 10 to 6 or 10 to 7 block error rate will be necessary, as well as the positioning and sensing accuracy is important, 1 to 2 centimeter. Well, massive connectivity is also an important factor. And as I said, well, tens of millions of devices will be supported per kilometer square. And although I didn't talk about coverage area, but the coverage area is one of the most important topics for the 6G era, even now, 5G era. So some industries want to have a massive coverage area, definitely. Well, space industry actually request us to have a coverage area outer space. So that's why we capture the requirements. So this is the radar chart. We're showing that the comparison between the 5G and the beyond 5G in terms of variety of metrics. So, well, I don't say in detail because time is limited. I only have 3 minutes from the time now, but what I want to emphasize is that, well, this radar chart shows that 5G requirements only for RAN, radio access network side. But what we capture is that not only RAN, but from viewpoint of industries, enterprise customers, they don't care about the RAN or core or transmission side. What they care is end-to-end latency, performances, and so on. So that's why we say E2E, which means that end-to-end. So this is the last slide before my summary slide. Well, this is the table showing that a variety of aspects. So actually, many industries have common issues and requirements and visions and so on. So actually, after listening to many comments and requirements from various industries, I summarized into this one page in terms of, well, for example, aging population and safe and secure, wonderful life and exciting future. So then, well, we can see another views like, of course, when we think about an aging society, then we have to utilize robots and autonomous driving has been also necessary. Then, well, we should have the kind of performances to in the beyond 5G, 6G era, and so on and so on. So I'd like to skip the rest of the contents, but you can download those contents from our website. So let me summarize my presentation. So I'm very happy to share the contents of possible use cases summarized in the Beyond 5G Problems of Conscience Day in this very nice conference. And well, there are several interesting but unique and very high hurdle requirements after listening to many comments from various industries, like 100 microsecond latency. And well, lastly, what I want to emphasize again is that industries, vertical industries, enterprise customers care about end-to-end only. So we have to revisit how to tackle with this issue from not only technology's point of view, but also international standardizations. Thank you very much.
A quick question, please.
Thank you, Satoshi, for good presentation. On your slide number 7, you had quite strong, you don't need to go there, I'm just repeating what was there. You made a very strong statement, and you had to be probably more precise on what you mean by that. You stated the IMT 2030 is evolution of IMT 2020. How can we say that since we don't even know yet IMT 2030 requirements? Number one, probably you meant that as use case perspective, it's evolution from 5G. Or do you really want to say right at the moment that 6G will be just evolution of 5G?
Okay, thank you, Matti, for your questions. So regarding the first question, I think, well, I'm going to say as a representative of KDDI right now, well, operators cannot satisfy all the requirements and requests from customers right now, even in the 5G era. So I think that 6G or beyond 5G should capture the requirements and try to satisfy the existing customers' requests at the beginning. That's why, well, we think that the beyond 5G and 6G era systems should be evolution of 5G because, well, we firstly satisfy the 5G requirements, and then that will be evolutionized little by little throughout the 6G era. So this is my first question. This is my first answer to your first question. And the second question is resiliency or sustainability, right? So yes, that is another very important point. So, well, sustainability is talking about not only various kinds of industries, but also I think telecom industry is also a very important factor. Unless we telecom industry cannot meet sustainability by ourselves, we cannot make them happy, make people happy, or other industries happy with sustainability, even sustainability point of view. So, well, the monetization is very important, as well as the energy efficiency is also very important. Well, regarding energy efficiency, I think many industries try to tackle with that kind of issues, right? So not only telecom operators, but also I think we have to collaborate with each other, not only with the telecom vendors, but also component vendors and vertical vendors. So that's why I think it is very important to capture and try to understand what kind of requirements, what kind of issues vertical industries, enterprise customers have. Is that answering to your question? Thank you.
We will continue the discussions in the coffee break. So, domo arigatou gozaimashita.
Thank you very much.
Thank you very much. Okay, the final speaker of this session will be Associate Professor Miguel Bordallo Lopez from, he's one of us, so from University of Oulu, from Center for Machine Vision and Signal Analysis, leads the strategic research area for distributed intelligence. His current focus on the convergence of computer vision and telecom using real-time video analysis and radio signals to sense humans. So he will be talking about the convergence of computer vision and communications. Go ahead.
Okay, thank you for the presentation. So when I was invited to give a talk here, I was given freedom to talk about almost anything I wanted. And I thought at the beginning that I was going to discuss this distributed intelligence and all the research that we have been doing in Oulu. But I thought I would use the opportunity to make some kind of statement of how computer vision and telecommunications are slowly becoming the same thing, and how computer vision is going to be an essential part of future communication research and development. And I will try to explain why I believe that. So it's possible to argue that both wireless communications and computer vision have been evolving as distinct fields. Even in our department, we are in 2 different floors, and we only meet sometimes in the elevator. So if we talk about wireless communications, we can see that we started trying to connect people by voice calls, and then we were moving to more rich data, then just to all types of data. And now I think in the last couple of generations, we are moving just from transmitting data to try to transmit what we see, and maybe even now what we understand. If we go on computer vision, it started with the mission of understanding the world through what we see with cameras. So we started with very simple shapes, recognition of shapes. We moved to the object detection, more complicated objects and their interactions, like, for example, all this face recognition, face analysis, all type of stuff. It came deep learning. Now we could throw massive amount of data into models and try to learn every single type of correlations and what they have. And I would say that the latest emerging thing is this vision foundation models, which are able to, in a large scale, you can basically send what you see, and they are able somehow to explain what is there. So basically, they tell you everything about the scene. So the needs of 6G is to understand the world, and this is what matching vision or computer vision provides. The needs of computer vision now is how can we distribute these big vision models all around the world. So I think we are doomed to actually converge and start doing the same thing. So I would say that the convergence happens at several levels. So it's a data level, algorithmic level, hardware level, application level, and they will become an ecosystem. I'll try to go through each one of them. So at data level, that I could say almost the physical level, in telecommunications, we are going to higher frequencies. At higher frequencies, the radio waves start behaving a little bit like photonics, a little bit like the light, not exactly. At the same time, in computer vision, we're exploring things that are beyond visible light, going far into the infrared as much as we can. So basically, we are going down in the spectrum. Telecommunications are going up. There are a couple of times that we have tried to jump. In computer vision, we have been trying to analyze sub-Earth images. In telecommunications, you can say that there is visible light communication, that they use visual spectrum to try to do communication. So at the physical level and the type of data that we get, we are slowly getting there. At an algorithmic level, when we talk about the needs of 6G applications, we are talking about localization, where the user is, mapping, where am I in the context, and even reconstructing the environment. So typical algorithms for this are the SLAM, simultaneous localization and mapping. This has been traditionally done with computer vision with cameras. Now there is this radio SLAM. They try to reconstruct the environment in the same way using radios. Distributed and collaborative algorithms. So algorithms for telecommunications were aiming at distributed information. Algorithms for computer vision were mostly centralized. Now they need to be distributed. We need all these distributed algorithms that are collaborative, both fields. And then we are all the time talking about more dynamic, adaptive environments and algorithms. So in computer vision, we want to understand change as fast as possible, even preemptively. The same in communication. So at algorithmic level, we are going the same type of ways. At the hardware level, I'm talking mostly here about computing rather than sensing hardware, but we have the basic unit of computation in telecommunications is the system on chip, and I would say that for computer vision is becoming the same way. So this heterogeneous multiprocessor that they have sensor processors, AI processors, DSPs, GPUs. We are slowly, if we are able to give access to all these processors to both applications at the level of computer vision and communications, they can be reused fairly easily. They are the same type of computations. Basically, it's matrix multiplications, multiplication and accumulations, filtering, same type of operations. Edge to cloud computing, distributing all these computations from centralized clouds into the all this continuum, all the continuum of possible computations. And finally, integrated sensing and communications, and even a new paradigm that is emerging where you try to do ISAC and learning at the same time. They are the hardware is already being shared by this type of applications. And at an application level, okay, I didn't go to the metaverse. I went just to mostly this collaborative telepresence, maybe something for telcos of now. But the applications of 6G, if we try to think all these use cases, most of them what they need is that we are able to process lots of streams of videos and make intelligent analysis of them in a synchronized manner in real time, very fast, instantaneous. And this is why we need mostly now the capabilities, even virtual reality, artificial or augmented reality, they need basically to process video very fast, low latency project radios at the same time. When we talk about for what we need computer vision, we need to understand the environment, understand what we see, what we don't see, what's going to happen. So for example, we could analyze the networks through this. So I would say that if we start developing these things together, then we are in the same ecosystem. We can start even trying to think some joint business models. So for example, we can consider aggregation and personalization of data. As we move, we are personalizing the data of the sensors in the way that we perceive them. We can donate our data as well to others and create maps of information. If it's in a privacy manner, there is some incentive for installing this type of sensors and to share this type of sensors if we can sell this information for personalizing for the people. Semantic slicing, we get sensors that only transmit what we mean or what we want to see, and they keep the other information. And of course, all type of map building. So as I say, all this is happening at all these levels. And if we start developing all together at the same time, then two paradigms emerge. First one is view to communicate, quite simple. We use vision to learn how to communicate, communicate to view. We use communications to learn how to view. So to try what they mean. So in view to communicate, the whole point is we could improve data transmission if we know how it's happening. So for that, we require mostly two things. Accurate mapping, knowing how the environment looks, and the electromagnetic properties of the material. And that way we can start enabling, because we know how the signals are propagating, we could enable no line of sight communications, multipath transmission, and we have impacts in all type of network applications. For example, this is a visualization tool for radio signals that ray trace how they are propagating. So we actually know what's in a fairly complex environment, how the signals are arriving. This is work that we've been doing. Building these maps is not easy, but now there's a lot of advances in the last year. So now we can build very fast maps quite fast. This is a map of the University of Oulu. It's only one building and it's almost 1 kilometer from one side to another. And we were able to collect this in a couple of hours just by walking with a Kinect, and then a few hours for rebuilding the whole environment. The problem is it's basically a geometric model of the environment that gives us visual information, so colors. This doesn't help for the radio spectrum. We have to move from 3D to what I call 5D. We have to incorporate at the same time as we are collecting this data, information in other parts of the electromagnetic spectrum that are useful for communications, and we need to add some kind of dynamics into that. So basically temporal structure. And I don't think the way is, of course, at the beginning, we can have a person walking all the world or a car walking all the streets, but essentially distributed modeling is needed. So we need to get information from all these sensors at the same time to re-reconstruct the environment several times, and telecommunications are needed for that. Once we have all these maps, then we can predict and interpret the environment. So computer vision reconstruct environments. The cameras are acting as sensors for real-time data collection. Now we can anticipate obstructions, not only see the obstructions. There's not only a car that is there that is obstructing my signal. I know the car is moving, the car will come, and I can already preemptively adapt. So basically, I can even simulate what's going to happen in a simulator and then make the network adapt. So it's moving from reactive networks into proactive networks, thanks to computer vision. The other paradigm, the other way around, communicate to view. How can communications help to view? Well, most of the cameras that we have now, even when you have these depth cameras or several cameras, they are still mostly monocular. That means that getting distance and depth is an ill-posed problem. So telecommunications are very good at measuring, or you can be with radio signals measuring delays using radars, or maybe the distance between a transmitter and a receiver. So if we have a monocular image, you can see up there in the corner, and we add a few priors of distance measured with other device, you can reconstruct the environment in a much better way. So for example, the one that you have in the middle has gotten 12 distant measurements done with a radar, and the one on the right doesn't. And it dramatically improves what we understand of the environment just with a few references of depth. Also, communications and radio signals can help us see around the corners. It will take a little more than 3, sorry. So to see around the corners, humans can already see around the corners if we think. If you think of a corridor that is completely dark in one side and makes a corner and then is illuminated, as a person is approaching in the illuminated part, you see some differences in the shadow, and you can already know that something is coming. In the same way, you can see these distortions in the radio wave. The main point of the radio wave is if we can actively steer and learn sensing strategies to see around the corner, and we can use other information that we have from that corridor when it had light to actually reconstruct what's going on. So basically increase situational awareness. Seeing through walls, it seems much more complicated, but in practice, it means being able to connect to sensors as you walk and project the information that you need to have. So basically, it means seamless visual coverage because you are able to connect to cameras or to models that are far away from where you are. And so these are the paradigms of the things that can be investigated now. So how do we do them? So there are tools available and in development. We are working in a few of them. So basically you have this camera-aided base station and the camera-aided intelligent surfaces. The point of the camera is twofold. In one of them, you can use them in conjunction with the radio signals to increase or to improve how they work. In another way, you can use the camera at the beginning to train models of how the radio is behaving. And then at some point, you can switch off the camera. But you learn particularly that environment sometimes. Doing this in the real world is very, very tough. It requires a lot of experimentation, a lot of data collection. I believe that this can be done quite a lot in simulation. We build realistic models, and then we simulate densely all these scenarios and start from a model that already exists. And there's a need of making machine learning exactly for this type of radio understanding. And we are working on all of this. And at the same time, we need to build experimentation environments. So in all, we are building a couple of them. This is a convergence chamber and digital twin. It's a real chamber where we are going to build all these tools during next year. So maybe by mid or the end of 2025, it will be ready and accessible as a European infrastructure for all. And at the same time, we are constructing a digital twin of it, so you can simulate all these experiments in the room before you go there and then make real measurements and see how they matter. And at the same time, we have this small multimodal sensing lab where we have a lot of sensors, cameras, radios, radars at the same time, and we are collecting data all the time and making models of the environment. So these experimental environments are needed. There are a lot of challenges that are not related maybe to science, but to engineering, system integration, demonstration of use cases, data representation and multimodality, device synchronization. I have seen many cases where you have a wireless link separated 100 meters or 20 meters. That goes very fast, but then you need to have a cable with a clock from one to another so you can synchronize both of them. This is not wireless anymore. And then, of course, as we are developing this type of applications, there are a lot of side effects of things that can be done that we don't intend to do, but other malicious actors could do. Problems with privacy, ethics, sustainability, they need to be addressed. So very fast, because they've been talking about this before. The three low-hanging fruits for me in the application space, in the automotive, now we are talking vehicle-to-vehicle communication, but it's about where they are and where they are going. I think understanding what one vehicle is understanding or seeing should be transmitted to the others as well. This is vision, basically. In healthcare, real-time, high-resolution imaging, in telemedicine and remote diagnosis, a lot of things can be done from far away. And in manufacturing, understanding how the manufacturing plant is working. So last 10 seconds, takeaway message. There's a new paradigm in research where computer vision, in my opinion, should be included in any telecommunications research or project as one building block. Hopefully, all agree. There are already tools available in development, so we are not starting from zero. There are substantial challenges ahead, but they're mostly engineering, so they are ones that are nice to tackle and to work together. And I think there's possibility of making potential impact in applications right away. So hopefully you agree. Thank you.
Okay, great. We have time for one quick question before lunch. So who wants to?
Thank you very much for your presentation. Quick question. Do you feel that somehow integrating computer vision and communications is contradictory to the integrated sensing and communications approach that many people talk about? Because many of the applications are trying to be addressed by sensing. Or how do you think integrating computer vision with communication fits in with integrated sensing? And
okay, that's a very good question. I think, no, this is not contradictory, because there are a couple of things that you need for integrated communication and sensing. Right now, we are developing ways and we are trying to deterministically measure and sense the speed or the position. I don't think this is the way in the future. I think the way in the future is to learn what we sense. And then we need to label a lot of data. Now we know the position because we put some markers on the floor, we walk, and then we take again. That's not the way. Computer vision can help for a while to train your model by providing labels to this radio sensing. So that's one of the aspects. And in another way, this integrated sensing and communications, they happen in an environment, and you still need to reconstruct the environment. You can reconstruct the environment to know the changes in the environment with integrated communication and sensing. But at the beginning, you need to build something much more accurate. I don't think at the moment, small radio device can reconstruct something at that level of detail. So cameras are needed. Maybe they are not needed all the way in the system, but they are an essential part of the beginning, especially during training and adaptation. And if they are there and they are usable, we can keep them and do more other things on top of that, because video transmission is part of the application. So as a part of the application for sensing is also interesting. I hope this answers the question.
Okay, thank you very much, Miguel.